So we've just finished the tedious part of finding the equation of the line of best fit on Desmos. Now we're going to do something similar to what we did in the last unit. We're going to interpret what each component of that equation means. We'll interpret the slope, we'll interpret the y-intercept, and then we're going to use that equation to help us make some predictions. So let's get started with interpreting that equation. So from our last video, we have found that the slope of that line was 187 and the y-intercept of that line was 43,777. So first question just says, what is the slope and what does the slope represent? So as we know, the slope is this value right here, 187. So I'm going to say the slope is 187. And as I did in the last unit, I'm going to write this over 1 just to help interpret what it means a little bit better. And I'm also going to put y over x, again, to help us interpret that better. So now we have to remember, well, what did y mean and what did x mean? You can go up to the table here. And the y stood for the price of the house, and x was the square footage of the house. So y is price, x is square footage. So we can go back down here. What this means is the price of the house, that's y, is going up by $187 for every 1 square foot. So approximately 1 square foot would be, something like a foot square, kind of like a tile on the ground or something like that. Every one of those square feet will add about $187 worth of value to the house. So I'm going to say each square foot adds approximately it's important to use that word approximately because it's not like 1 square foot is automatically going to add 187. It's just, in general, the larger the size of the house, the more it's going to be worth. So it comes down to each 1 square foot adds approximately $187 to the value of the house. So that's the slope. Take the slope, write it as a fraction with a 1 on the bottom, and then interpret it using the y and x variables. Next, we have the y-intercept of the equation. So if you come up here, this value here, the b value that we found, that's going to be your y-intercept. If you remember, a y-intercept is just wherever the x equals 0. So if you were to replace this x with 0, all of that goes away and you're just left with 43,777. So there's your y-intercept. I'm going to write that as a coordinate. 0, 43,777. And now we have to figure out, what does that mean? 0, remember that's an x coordinate, and this is a y coordinate. X stands for the square footage of the house. So if you have a house that is 0 square feet, basically it doesn't exist, you still might have to pay $43,777. Does that make sense? I think it does. You still have to buy the land that the house is going to go on. So even if you're not going to be building a house on there, the plot of land that you're going to buy, you're going to ideally build the house on, still costs money. Some plots of land might cost $200,000. Some of them might only cost $15,000. But in this case, it says it kind of averaged out to about $43,777. So even if you don't build a house, you still have to pay for the land. So I'll say a house with 0 square feet, one that doesn't exist. Square feet, I'll abbreviate that. So a house with 0 square feet still costs $43,777. And then you could build the house on that land if you wanted to. So that's interpreting the slope and the y-intercept. And now what we're going to do is we are going to use our equation to make predictions. So first one says, a family is deciding to sell their house in St. Paul. Sad to see you go. They have taken measurements and they've determined that the size of their house is 2,000 square feet. Approximately how much do you think this house could sell for? So what we're going to do is we will always just start with that equation. So it's important that we found the correct equation. We have y equals 187x plus 43,777. So just start with the equation that we found and then take the information that was given to you. Here it says, we know that that house is 2,000 square feet. Now is square feet an x or a y coordinate? Well, if you forgot, come up here. Square footage was the x coordinate. So we can replace the x with 2,000. So we'll rewrite it. So all we did there was we replaced the x with 2,000. Then we can take 187 and multiply it by 2,000. And we end up with 374,000. And then plus 43,777. And if you add those together, it gives you the value of that house is approximately $417,777. That's approximately what they'd sell it for. Now, if you're a realtor, you're not going to post a house for $417,777. That seems kind of odd. You'd probably just bump it up to like $419,000, because what's another $1,000 or so? So realtors would probably round it up to a nice cleaner number than that, but it's approximately worth that value, $417,777. All right, now we get to Lena. And Lena just won the lottery and decides to buy her mother a home in St. Paul. Very nice of you, Lena. She will spend $1 million on her mother. Extremely, she must have really won a nice lottery. $1 million goes to her mother for her house. So I want to know approximately what size of house would you expect Lena to be able to purchase. So she got $1 million, so you're probably going to be able to buy a pretty big house for that. Let's start with our equation again. So we have y equals 187x plus 43,777. And then we take the information that was given. We know that she's going to buy a house that's worth $1 million. Now, is that house value, is that the x or the y? You're correct. That's the y coordinate. So we're going to replace the y with $1 million, 1 with 6 zeros, equals 187x plus 43,777. So all we did was replace the y with 1 million. So now what we have to do is we have to solve for x. So to get x by itself, let's get rid of this 43,777 on both sides. And if we take 1 million and we subtract the 43,777, it becomes 956,223 equals 187x. And then to solve, we can divide by 187. And if we take that number and divide it by 187, we get x equals 5,113. I'm going to leave it at that. We're not going to use decimals on this one because no one measures a house with 0.49 square feet. So just round it to the nearest square foot. And this is going to be 5,113 113 square feet worth of house. That's a really big house, which you'd kind of expect. If you're spending $1 million on your mother for a house, get her something nice. Now, mom's going to have to clean that every once in a while. Probably doesn't want that big of a house. So if you're going to get your mom a house for $1 million, don't get her one that's 5,000 square feet, because that's a lot of house to clean and keep maintained. So that's how you can use a linear regression. We can find the equation, and then we can use that equation to make predictions. So hopefully that was helpful for you. You're going to have a chance to do a handful of these on your own. So thanks for watching, and go ahead and get started on your next couple assignments.